We'll go ahead and get started. Thank you all for coming this afternoon. I know it's getting late, our brains are getting tired. Hopefully this won't be too much cognitive overload. It might be for me, so if I lose my way, you'll understand. My name is George Fletcher, and I work for AOL. I'm the identity architect at AOL, responsible for enterprise, business, and consumer identity. Though officially we are no longer AOL, we are Oath, but the brands will stay, and that's a whole nother conversation. You can ask me about that and what that means later if you are really interested. So what I want to talk to you about today is identities, and they're all around us, right? For the longest time when we think about B2E, B2B, and B2C as mechanisms for dealing with identity in our industry, we think about people, right? Lots of people, but people. But obviously that world is changing. We hear tons of stuff about IoT. Sal gave a talk earlier this week on identity relationship management. Nully gave a talk on doing fine-grained access control with graphs. All of those things are sort of starting to look at more than just people and relationships between people, but looking at people and relationships to things. So relationships are critical, and we have 20 minutes to talk about identity and graph, and there's not a whole lot you can cover in 20 minutes and this. So think of this as sort of like, what are the core objects at the very base or at the very nucleus of an identity model, and how do they relate to each other? And even in that small space, we will see that there are lots of relationships and important relationships between these different objects. So I want to talk about, sort of build this up, talk about a series of objects or nodes of the graph. What are those things? Talk about some relationships, how these nodes and objects relate to each other, and then look at some use cases. How do we apply this then in some common identity use cases that we have today? So we're going to start off with an identifier. It's kind of hard to have an identity without an identifier. Even if you're thinking about anonymous, attribute-based access control, you still have an identifier. I need to be here? Sorry. I like to move when I talk, but... Is this better? Okay. We still need an identifier, and I would argue that all identifiers have both an issuer and a subject. Now these you might consider to be words or terms from OpenID Connect or the Jose spec, but pretty much, as you'll see in a minute, any kind of identifier has effectively the authority of the domain who's issuing it, and then the actual identifier itself. So if we think of identifiers as an abstract base class, for the techies in the room, right, you have an email address. Well, the issuer of the email address is its sort of email domain. Subject could be the local part. What about a phone number? Well, a phone number is issued by an MNO. Now, you can move your phone number, and the issuer will change, right? But there is, at any one given point in time, there's an authoritative domain for your phone number, which is your mobile network operator. Even distributed, or DIDs as they call them, for distributed IDs in the blockchain world, you look at the DID spec, it explicitly has a method section of the spec. And I won't go into the details of that here, other than to say that the method defines the authority or the domain of that actual distributed identifier. What about other things we're more used to? Usernames, GUIDs, and things we use internal to our identity systems to represent entities or things, right? And even a JWT effectively has an identifier. It's got an issuer, and it's got a JTI. All right, so there's an identifier. An identifier is a critical component of our identity systems because that's how we reference things. What about entities? An entity has a unique ID, or probably should, right? Some name, some description. There's obviously many more things you can consider from an abstract base class kind of a model for entities, but these are three I used for sort of explanation in this talk. So we can have user entities. Those are pretty normal. We're pretty used to what those are. A device entity, maybe a phone, maybe a Nest, right? You can have an application. An application is an entity in your system, and you'll see where this becomes important later on when we walk through the use cases. You can have groups, and you can have roles. And I sort of threw these in there so that we can look at sort of role-based access control and how you might do that in a relationship model. So let's look at these in a little bit more detail. We've got a user. Whether TOS version should be part of your user, I don't know, but some models might have that. A device, manufacturer. Our phones have an ad ID, and we can go and reset it, right? So it's just an attribute of the device. When you activated it, maybe the model number of the device. Thermostats, right? These are kinds of entities. An application might be who wrote it, who the admin contact is, ops contact. These are all important things if you're thinking about doing OpenID Connect, right, and you have a client, right, these are important things you'd want to track about your application. So moving on, credentials are our favorite thing for authenticating people, or things for that matter, actually. So we can have passwords, we can have private keys, TOTP pushes, ASQs, except for we don't really want to use ASQs anymore. I know KBA is sort of important in lots of places, but the ASQs that we tend to answer, we tend to give a less secure value answer to the ASQ than we do to our password. So trying to recover your password with something less secure than your password seems a little weird. I hope that we get away from this as a model for identity. And then lastly, I want to talk about tenants. And I'm not going to spend a ton of time talking about tenants, but in a lot of cases, you want to build a multi-tenant infrastructure. And so when you do that, these things need to be part of a tenant. So you would have a relationship between your objects and the tenant. Now, what kinds of attributes would you put at your tenant level? Well, we've had some cases for some of the things that we've done at AOL where maybe the tenant has a very low-risk kind of environment, right? All they do is they need people or things, and they need to be able to leave comments, right? Well, their password policy might be quite different than, let's say, the password policy of someone who's trying to check their mail, right? On the mail side, it might have a much stronger, the mail tenant might have a much stronger password policy than the commenting system. So that was sort of just to illustrate that there are attributes about tenants that are important to track from an identity perspective. So let's talk about some relationships. Obviously, all of these things can be members of tenants. That's pretty straightforward, not too complicated there. What about the sort of normal user that we have in our identity systems, right? I have an identifier that's a username. Maybe I use that for login. Maybe I have an identifier that's an alias to this user. Maybe I have many identifiers that are aliases to this particular entity, right? And then associated with this entity is a credential, right? Now, in this particular case, in this particular model, I call them first factor and second factor because I couldn't think of anything better. But obviously, the cool things about Graph is that we can name those edges whatever we want, right? So you can come up with a much better model and set of names than I did for this talk. But there's some relationships. Devices. Maybe the identifier for the device is the serial number and the manufacturer. And the credential for the device is a software statement. So anybody here familiar with OAuth 2 and dynamic client registration? A few people. So a brief sort of rabbit trail here. OAuth 2 has a mechanism to allow entities to dynamically register with the authorization server. And one of the ways that you can do that is you can basically prove that you're allowed to register with that authorization server by presenting a software statement. The software statement can be embedded into the device at manufacturing time. So this is effectively a credential right, for the device represented by this identifier. Applications, I just used an OpenID Connect model, right? You could say the client ID is the identifier, you have the actual application and what it does, and you have the client secret as the credential. Finally, for the kinds of things we're going to talk about today, we have the sort of groups and roles. So in this particular case, you could say a user is a member of a group enables a role authorizes an application. So this is just one way to think about the relationships between these objects within the identity system. Tracking with me so far? Okay. All right, so let's sort of start putting it together a little bit and see how this works out. So if I want to do a login, right, through a model like this, what's the user going to present? The user's going to present their username, right, or maybe their email alias if we support logging in with either, right, which is a possibility given that relationship I showed you earlier, right? So I'm going to take that identifier, I'm going to go and I'm going to say, find me the person or the user entity, right, that's in a login relationship with this identifier. All right, all right, great. Got the user now. So now find me a first factor credential, right, for this user. And maybe there's more than one, right? It doesn't have to be just one. That's the cool thing about Graph, right? We could have multiple credentials, first factor credentials that work or that this user has as options to them. And maybe, Yahoo supports something called account key, which is sort of like a phone-based first factor credential. Maybe that's what you find. And maybe you get to pick as the authorization server, right, which of these first factors do I want to use in authenticating this user, right? If the user has MFA enabled, maybe I need to go find the second factor. And maybe this is a push notification. Well, I need to push it to something, right? So I'm going to deliver it to a phone, right? So the relationship of which phone to deliver it to is maintained by our deliver to edge in our graph. And now I can also determine, is this phone really used by that user? Because maybe I don't want to push it to a phone that isn't actually used by the user I'm trying to log in, right? And then, of course, the phone probably has an identifier as a number. What about sort of registering, like an IoT device registering into an authorization environment? So one of the things that I kind of feel like as it relates to IoT is that in today's world, everything is sort of what I'm going to call manufacturer-centric IoT, meaning that your device connects to the manufacturer's cloud, and you interact with your device via the manufacturer's cloud. So you've got to go to the manufacturer, you've got to create an account, you've got to identify your device, and then when you tweak it, the message goes up to the cloud, back down to your device, right? What if I wanted an environment where the device registers with an authorization server or an environment that I control? Doesn't mean I might still give permission for the manufacturer to gather information about that device. Maybe I give the manufacturer capabilities to auto-update the software on the device, but it's more in my control, which I would consider being more of a user-centric IoT model. I don't know if I'll ever get lucky enough to actually see it implemented in real life, but that's my dream. All right, so a little bit of background behind this one. So the device basically runs an application. The application needs a client ID and a client secret. So if you think about this, let me explain it a little bit more carefully. The device is going to go to the authorization server, right? The authorization server doesn't have data represented in our graph model. So the device goes to the authorization server, says, here's my software statement. I need to register myself, right? And I'm going to perform this application, right? The authorization server says, okay, great. I'm going to effectively issue you the device a client ID and a client secret, and that client ID and client secret are in the context of an application that the device is performing for me, right? Not necessarily on my behalf even, but performing for me. So we've talked a little bit about sort of devices. We've talked about standard user authentication. I wanted to have a use case that pulls in device endpoint authentication. So one of the things that's happening a lot today in the identity space is that we're trying to authenticate the device the user is coming from, right, at the time of authentication as another factor in determining whether it's really the user or not. So we can represent that in our graph. So we take the username, we find the user, right? The browser can get fingerprinted. So we might not be an exact representation or an exact sort of identification of the user, but it's a really, really good one. And I don't know if anybody remembers the EFF website from 4 or 5 years ago, right, where you could go to the EFF website with your browser and click this button, and it would tell you how unique your browser was. Like, what's the population of people that have that browser, right? And it was really surprising that, if you had installed N number of extensions into your browser and you had these sets of fonts on your computer, you got down to a really small population. There are other ways to fingerprint browsers. So let's just assume that the users come in, we've written a cookie, this is the standard sort of, simple way of doing it, but for the purposes of this talk, that should suffice to represent the relationships. So we have an ID that represents the browser is an entity in our system, right? And we've basically created a relationship that this user uses this browser, right? So when they log in, right, we can basically validate this set of relationships. And if the user doesn't actually use the device that they are coming from, well, maybe that's a sign that we need to do step-up authentication. We need to add a secondary level of credential into the system, right? And the rest of this is pretty straightforward. This case, we're using sort of an SMS flow for second factor, though if you all know, NIST recently published a specification that says don't use SMS. So if you're using SMS for your OTP or second factor mechanisms, it's time to start looking for something else because that one's no longer considered safe. All right, so then to put it all together, and we have a couple more minutes here, so I think we're pretty good. A client, think about this in an OpenID Connect sense. So let me set it up. I realize it's kind of hard at times to map between the user flows of what's happening and the underlying graph that's needed to support them. So I, as a user, go to a website. The website's going to use OpenID Connect to log me in, right? And the system's going to try and determine, am I allowed to actually access that website, right? So that's sort of the high-level use case we're going for here. So in your OpenID Connect flow, when the OpenID Connect relying party redirects to the authorization server, it will send a client ID. That's where that client ID comes from, right? So we can go look up the app and say, which app is this, right? We get the username and we get the browser like we had before in our other examples, right? We can look that up. We can determine that the user uses that browser. We can find the factors. We can authenticate them via those factors, right? Verify that this user is valid within the system. I can then basically query to see, is this user part of a group? And is that group associated with a role? And is that role attached to that application? Now, there are many other ways to probably represent groups and roles in a graph model. So this is just, again, purposes of the talk perspective. But what this allows us to do is, if I don't make it to the app that started this request in looking up the user's capability, then I don't even send them there, right? So think about it as coarse-grained authorization. They don't have access to the app. They're not in a path that would give them access to the application. So even if they started the authentication from there, there's no reason to send them back there in an authenticated state. And maybe I don't even write my authenticated cookie into the browser because if this is the first time I'm seeing them, there's no need. They weren't allowed to go to where they were trying to get to. All that can be represented via these relationships in our graph. So if we put it all together, we get something like that. I couldn't figure out how to draw that in PowerPoint, so you get the omnigraphal version. But this is effectively all the relationships from a class perspective, not an instance perspective, that we've been talking about today. And with that, we're right at about 20 minutes, and we can go to questions. Here, you can use this one. I don't need to walk around anymore.
This is just for a clarification. I heard you mentioning that using SMS as a second factor is not safe anymore. Can you actually elaborate a little bit more on that?
I'll try and elaborate a little bit, but effectively, it's relatively easy to get a number SIM swapped. So, and in addition, it is phishable, right? You can get the user to give you the value. So both of those are reasons to not use it. Same is true for, in the sense of the phishability, a Google Authenticator app. Potentially a little bit better than SMS because you actually, it's bound into the device, but similar kind of scenario. There's one in the back.
So my question is, if you talk about relationship, graph databases, are you using graph databases with IAM at AOL, or is it basically a way to solve the problem? And the second part of it is graph is interesting for us in the sense that if you think about relationships in terms of a customer, partner doing something, partner operating a device, partner RMing a device, and all kind of relationships that you look for, it solves it, but I haven't seen a practical implementation of it in an IAM world. So are you talking about, yeah.
So good question. At the moment, we're not using a graph database, though we've been looking at a number of in the sense of storage, and looking to see what we can do from a sort of a scale and a performance perspective, right? It's great in the academic sort of thought exercises. Can you handle billions of probably tens of billions if you think about IoT in nodes and edges in your graph, and and what do you do about geodistribution and issues of certain countries requiring that their users' data be in their country, and there are a lot of those kinds of things. I think Neo4j has come up with some additions, but for the longest time you could not shard nodes, which creates issues from a geodistribution perspective. We've looked a little bit at OrientDB, which is great from a sort of exploratory kind of a model. Whether it, from an enterprise perspective could handle it, we haven't got to that level of testing.
I just wanted to help out with some of the guidance from NIST regarding SMS. Actually, it is allowable provided you can ensure that the phone number that you're using is a cell phone and not VoIP, because the exploit is that the numbers get hijacked over to VoIP. So NIST does allow for SMS, but under very specific circumstances, provided you can guarantee it's getting to the right type of endpoint.
Great, thank you.
Any other questions? Could you talk about the permissioning of the objects within the graph? I mean, you don't imagine that every actor would be able to traverse every node in the graph in a particular flow, even for an individual user.
So it's an interesting question. I don't know that I spent a lot of time thinking about it. I would think about actors traversing the graph to be from things more from the perspective of an authorization server or another component of the identity system. And I could see in that particular case, there could be restrictions on access to particular node types or whatever, like, maybe only the authorization server that's going to be validating credentials that can actually have access to the credential nodes. But I don't think about it from the perspective of a user traversing the graph. At an admin level, that's another thing, right? Which admins have access to which sets of data. I don't know. I know in looking at OrientDB, I don't remember them seeing any sort of particular thing that was around saying this particular admin user only has access to these sets of data within the set. But I think it's a great point. I would think that from an admin perspective or from an application perspective, it would be great if you could restrict, in certain cases, their access to nodes and edges within the graph.
Probably time for one more.
This is a follow-up on the question on GraphDB. So you mentioned GraphDB and IoT also. So for the IoT, are you recommended to using GraphDB to store the information, or relational database is fine?
So, it's a great question. There are lots of issues you have to take into account, right? And when you look at architecting a solution, it's which are the most important, right? So if geo-distribution and sharding and global replication, well, maybe you want to look at Spanner from Google or CockroachDB or some of those natures, but then to get your graph, you're going to have to basically build it in memory, right? And that can be complex, right, from a software development perspective and from a management and, ensuring that things don't, everything happens to go through the in-memory graph before it gets to the database so that, data stays in sync. I think that as a model for representing the problem, it's a critical component of your model. So, I would highly recommend in a large IoT world that you look at a graph as a model for how you're going to represent the items and their relationships. Because in many times, I don't want it to be George's nest, right? I want it to be a nest on its own that I'm allowed to, to affect, right? I can change the temperature on it. But it doesn't need to be George's nest, right? And so I think that from that perspective, it's important to model your problem from a graph perspective. But then I think when it comes down to real implementation, there's a lot of experimentation and learning that still needs to go on. I know ForgeRock has been, and Nully have been doing stuff with identity relationship management. Yeah, there, you're in the audience. So they're doing a lot with that as people who have experience in large-scale deployments. That may be a place to look as a starting point. There are a number of GraphDBs that are out there to also play with, but I've not gotten to the point of doing enough experimentation to prove performance and scalability for our uses. All right, thank you very much.